Welcome in chapter 4. Today I have plan for you to succeed. And in this course, today we're going to talk about chapter 4. In chapter 4, we're going to deal with imperfections in solids. We need to know what imperfections in solids are, because only when we know imperfections we can able to control, and we want to control materials. We want to understand the importance of materials. So, in this chapter we're going to talk about vacancies and self-interstitials. What are these things? How do you able to control these things? It's very, very important for you. And next we're going to see impurities in solids. How solids materials substitute one another when we have copper and zinc, for example. How we can combine these materials so that we can able to control it right from the atomic scales, so that we can able to make a lot of uses of it. We have the specification of compositions. This is also very important, because when we are combining, we are alloying these materials. That reminds me of cooking. When you are cooking, you mix things together. This is the same thing that is happening in material science and engineering. You are alloying the materials. If you have copper, you have zinc, you have to able to understand how many of the weight of copper is there, and how many of zinc, and atomic percent and weight percent. So that's why you can see composition of an alloy in terms of weight percent, in terms of atomic percent, and how you can convert from one unit to another. This is very important for you to know, because only then you can able to, like I always say, control these materials. And we want to control these materials. We want to reduce some emission within the atmosphere. Then we're going to see dislocations, linear defect. Every material have defect, regardless whether you human beings, we all know human beings are not perfect. It's the same thing that is applicable in the materials. There are imperfections also in materials. We're going to see that in this chapter. We're going to see edge, screw, and mixed dislocations, and how we can calculate that, and what are the vectors we look out for. We have the Bogas vector. We're going to see that as well. And next we're going to see interfacial defect. We started this in chapter 3. When we talk about grains, we talk about grain boundaries. It is very, very important from the surface of the material. How can you determine the effect or the defect that these materials have, and also the grain boundaries, as well as phase boundaries and twin boundaries. So these are the things, because when you know these things, you can able to manipulate materials, you can able to transform materials to any type that you want, and this is very, very important for you to know that. And we're going to see bulk vectors and atomic vibrations, because we have modeling, we have been modeling atoms as circles. But remember, these atoms are vibrating. They are vibrating. This is, will take us back to chapter 1 when we talk about atomic bonding. These atoms are not stable. They are vibrating. And this is the vibration that we are working with to know the temperature. So temperature is just like atomic vibration. So if you know thermodynamics a little bit, or you have the understanding of thermodynamics, this will help you greatly. But if you don't worry, we're going to demystify it. That's why we have this course, is to help you to understand the basics right from the foundation of material science and engineering. And we're going to talk about microscopic techniques, because if we can talk about these things all day, if you cannot see them, if you cannot feel them, then it's very, very difficult for you to grasp these ideas or these informations. But then we're going to talk about it from the microscopic level, how we can use microscope to able to see grain structures. We talk about atoms, we talk about electrons and protons, but we need microscope. So yes, and next we're going to see grain size determination, how we can determine these grains. Okay, we have methods that we come up with in order for us to be able to determine these grains and the average and the grain size number. Why at all? So this is basically chapter 4, imperfections in solids.